Welcome to August 18th LeetCode Challenge, Decode Ways. A message containing letters from A to Z can be encoded into numbers using the following mapping. A goes to 1, B goes to 2, all the way to Z goes to 26. To decode and encode a message, all the digits must be grouped, then mapped back to letters using a reverse mapping above. There are multiple ways. For example, we have the string digits string of 1101. It can be mapped into either AAJF, which is a grouping of 1 separated 1 separated 10 separated 0, 6, or it could be KJF, which is a grouping of 11, 10, and 6. So note that the grouping 1, 11, 0, 6 is invalid because 0, 6 cannot be mapped into F since 6 is different from 0, 6, right? The strings are different. Given the string S containing only digits, return the number of ways to decode it. It's guaranteed to fit a 32-bit integer. Okay, let's go for some examples here and kind of massage out the question a bit. So we have a string here with 1, 2, so 12, and it's asking you how many ways can we decode this. So there's two ways, an output of 2, number of ways we can decode it. Either it could be 12, which corresponds to decode, 1, 2 could be decoded as either A, B, so that's 1, 2, or it could be 12, which is L. Okay, so there's two ways of doing that. Another example is that we have S being the output of a string of 2 to 6. So there's three possible ways to number of ways to decode it. So 226 can be decoded as BZ, which is 226. It can be 22.6 for VF, or it can be 226 individually, which is BBF. Right? There's three ways to do that. So we have a base case as well. So if S is equal to string 0, 0 is a valid string in the, in the mapping, but however, the output of 0, string 0, is 0 because there's no character mapped onto the number starting with 0. So the mapping is only valid between with 0 or J, which is 10, and T, which is 20, but neither of them start with 0. So hence there's no valid way to decode it because all digits need to be mapped. Likewise, if we have a digit preceding a 0, right? It cannot be mapped onto F because leading zeros don't count. And our constraints will be between S's length of S between 1 to 100, and S only contains digits and may contain leading zeros. So we need to take care of that outlier. So how are we going to do this? There's many ways of doing it. One of them is memoization, and there's another dynamic programming one. I'm going to go with the dynamic programming one, and here's how I'm going to explain it. So we're going to build a DP array, dynamic programming array, and it's going to store the number of combinations, the possible number of ways to decode a length of a string. For example, if you have a length of string 0, length of 0, that means it's going to return 0 because that's the only option. Right? We have a strength, I'm going to say length of S. So the length of S is 0, then we're going to only return 0. If the length of S is 1, how many ways can we return that? There's one way to return a string that has a string of one character that has one output. Barring that, we have to take the exception of 0 as well. Base case, I should say. Barring base case of 0. Right, it's 0 right here, can only return 0. So we have length of 2, right? If S is the length of 2, how many ways can we encode it, right? So if you think about it, there's, if you have, for instance, you have 0, 1, right, which is character length of 2, that returns 0, so barring the base case, right? And if we have, let's say, for instance, 22, oh no, 12, let's say 12, right? So we have a possibility of them being separated, or they can count together being a single letter, right? And there's the limit is being a 2-character number is that there's maximum of 2 ways, if the number is within 22 and 26. So there's two ways of doing that. And then what if the length is 3, right? Length of 3. So we add from the previous answer, because the previous answer is always added to the next one. But how many ways can we make a possibility of 3 characters? We see here that we either be the maximum way to make encoded a 3-digit number is we have 3 ways of doing it essentially, because it could be the first digit alone, comparing the last 2 digits to the group. We have the grouping of the first 2 digits and leaving the last digit alone, or it could be in 3 individual piles, right? So there's 3 possible ways of doing it, barring obviously the leading zeros. And then we kind of continue building this on this principle using the dynamic programming array, because every time we just increase the index going downwards, we have a number of different possibilities, right? Obviously, you want to keep in track that the string has to be between 1 all the way to 26, and we need to take care of the base case of 0, right? And that's pretty much it, and that's how we're going to go about solving this. So the first thing I'm going to start off with is if not s, then we're going to return 0. If s does not exist, then we're going to initialize our dynamic programming array to be the length of s minus plus 1. So length of s plus 1, right? Because we want to have an additional length onto that. So our first thing we're going to do is our base case. So dp of index 0. If that's equal to 1, well, we have to take care of it, make it equal to 1, I should say. So if the string at index 0 is not equal to the string 0, then we want our dp at index 1 to be assigned to 1. That's pretty much bringing from the previous index the combination length possibilities from the previous index to the next index 0 to index 1, if the string at index 0 is not equal to 0. Alright, now to propagate through our dynamic program array approach. So we're going to do an iterator. So for I in range of 2, because we're already on the second index, length of s plus 1, right? We want to go all the way to the index, the length of plus 1. So if the current character is different than the string 0, we can add it to the sequence, right? And the number of combinations remain the same. So we want to make sure that if we take the answers from the previous index and move it, we add it to the next index possibilities as well. So if the string at index I minus 1 is not equal to 0, so it's not basically a leading 0, so we're going to update our dynamic program at index I to be incremented with our dynamic programming array at the previous index, I minus 1. Because keep in mind, dynamic programming array, we are making our answers at the current index based on our previous index number in the dynamic array. And we're going to take that number and add it onto the current index if the index of the previous string is not equal to 0. Now we need to check the pairs. So the first element of a pair is 0. Obviously, if it's a leading 0, then we skip it. We continue. So if needs to be within the loop as well, s at I minus 2 is equal to the string 0, then we are going to continue, because we don't need continue. Because we don't need a leading 0 inside the middle of the string, because 0, for instance, we have 0, 6, that doesn't mean anything, right? We can't, the output is 0, so we can't add anything to it. I mean, adding 0, we can add 0 to it, but it doesn't mean anything, so we're going to continue. So next thing we're going to look for is the number has to be, if the first element isn't 0 and the pair is within the range 1 to 26, we can consider that a possible pair, that being one element representing a character in the x minus 2 position. So that's a long way of saying we are going to find a character. We're going to make a new a variable here, n, which is going to be I minus 2 plus s at I minus 1. And if that's basically finding the value of our current character, if the string is between basically 1 to 26. There's an easier way of doing this using ordinal numbers, but this is what I first came up with, so it's fine. And then if that's the case, if the current character that we're in is between 1 to 26, it's a valid character, so therefore we're going to increment it because it's possible to make a character out of it, and so it's going to be the I minus 2 position. So we have all that. Now we want to return basically the dynamic programming array at the last index, because that's going to be our answer. So let's run this and see how it goes. Accepted. Awesome. So accepted. So the time complexity is going to be big O of n, for n where n represents each character inside the string s, because you do a for loop through the range of it. I mean, obviously we start at 2 and go the length, but it's close enough. Space complexity is big O of n as well. It's the size of the dynamic programming array, right? And the size of the dynamic programming array is based on the length of a string s. So both space and time complexity is big O of n, where n is the length of s, which is our string. Alright, that's pretty much it. Have a great day, guys.